this motor winding arrangement works. For understand windings, we start from the basic. We have a copper wire as conductor. When we flow the current through a conductor, the magnetic field is produced around the conductor. The direction of magnetic field is according to the right-hand thumb rule. When we make a coil with this wire, then flow a current, then it happens some interesting. To understand, we break the coil in two parts. The current flow in one side of coil is opposite to the another side. That's why the direction of magnetic field is also different in two sides. You notice that the direction of magnetic field of coil is like a bar magnet. So the coil makes a north and south pole like a magnet. For increase the strength of magnetic field, we increase the turns of coil. This winding produce a two-pole magnetic field. But in electrical motors, we use 4-pole, 6-pole and other pole magnetic field as a requirement. For produce a 4-pole magnetic field, we use one more winding in series. There is a 4-pole magnetic field as shown. We make a winding for a 3-phase induction motor. For this do some calculations. We place a winding in stator core. In this stator core slot is provided to adopt the winding. There is a total 24 number of slots. We consider our motor speed is 1500 rpm. We put this motor speed in synchronous speed formula. The number of pole in this motor is 4 if frequency is 50 Hz. Coil pitch is 6 for this winding. The coil pitch or coil span for winding is according to formula. It is the angular distance between two sides of a coil, measured in terms of armature slots. Number of slot is 24, so according to formula we use 12 coils. This is a 3-phase motor, so there is 4 coils for each phase. For making 3-phase induction motor self-starting, winding displacement is 120° electrical for each phase. So, the phase angle between two adjacent phases is 4, according to formula. Let's insert the winding in stator core. We insert first coil of R phase in slots. See that the one side of coil is in slot 1, and the other side of coil is in slot 6, because the coil pitch is 6, for this winding. Second coil of R phase is between slot 7 and slot 12. Third coil is between slot 13 to slot 18. And the last fourth coil of R phase is between slot 19 to slot 24. First coil of Y phase is start from slot 5, because phase angle is 4. The second side of 10 according to coil pitch. The remaining all 3 coils are arrange as R phase. First coil of B phase is start from 9 slot, according to phase angle, which is 4 from Y phase. All coils of B phase is arrange as R and Y phase. Let's do connections of this winding. For better understanding, we make stator in linear shape, rather than circular. We connect the ending point of first coil with the ending point of second coil. Starting point of the second coil with the starting point of the third coil. And ending point of the third coil with the ending point of the fourth coil. When we flow a current through this coil, the current flow from first coil to fourth coil of the winding. According to coil connections, this current produce a magnetic field around the each coil, according to its path and current direction, and make a north and south pole like a bar magnet. This same connections is done for other 2 phases. As you've seen, by this, we produce a 4-pole magnetic field in all 3 windings. This coil arrangement type is a 24-slot, 4-pole, single-layer, distributed winding, which is most commonly used in 3-phase induction motors.